In this video, we will explore different questions based on cutting of a painted cube. And while solving these questions, the most important part is to visualize the cube and the cutting process. This is a typical figure of a cube. The dotted line shows the part of the cube which is hidden behind. There are 8 corners or vertices in a cube. This shaded region represents one of the 6 faces of this cube. So in total there are 6 faces. One behind this shaded face, 2 on the sides and 2 on top and bottom. The blue line which you can see is representing an edge or a side. In total there are 12 edges. Now let's figure out the maximum and the minimum number of identical pieces formed when different number of cuts are made on a cube. We start with only a single cut made like this. It divides the cube into 2 identical parts. Both the minimum as well as maximum number of identical pieces are equal to 2. Next case is when number of cuts are equal to 2. To get minimum number of identical pieces, we have to make these 2 cuts along the same face of a cube. Here we get 3 identical cubes. But if we make a single cut on one face and the other cut perpendicular to it, then in that case we get 4 identical pieces. So minimum pieces will be 3 and maximum will be 4. Now when number of cuts are 3, minimum number of identical pieces that we will get in this case are 4. For maximum number of pieces, we have to make those 3 cuts along the 3 dimensions: length, breadth and height. Number of cubes that we will get here will be 4 in front like this and 4 exactly behind these front ones. In total, we will get 4 plus 4 equal to 8 identical pieces. To generalize this, if number of cuts along length, breadth and height are A, B, C respectively, then minimum number of identical pieces will be total number of cuts, that is A plus B plus C plus 1. Maximum will be A plus 1 into B plus 1 into C plus 1. Let's look at some examples. First example says that if 21 cuts are made on a cube, then we have to find the minimum and the maximum number of identical pieces that are formed respectively. Here total number of cuts A plus B plus C is given as 21. So minimum number of identical pieces will be A plus B plus C plus 1, that is 21 plus 1, 22. For minimum pieces, all the cuts were required on a single face. But for maximum pieces, we will distribute the cuts equally along the 3 dimensions. To distribute cuts for maximum pieces, we take the total and we divide it by 3. 21 divided by 3 is 7. So the cuts along length, breadth and height will be 7, 7 and 7. Maximum number of identical pieces will be A plus 1 into B plus 1 into C plus 1, which is 7 plus 1 into 7 plus 1 into 7 plus 1, which in turn gives us 8 cube, or say 512 as the final answer. Let's take a case in which number of cuts cannot be distributed equally along the 3 dimensions. 22 cuts are made and maximum number of identical pieces are asked. Suppose these 22 cuts are distributed as 8, 8 and 6. In this case, maximum identical pieces will be 9 into 9 into 7, 81 into 7, 567. But this is incorrect. If the distribution is 7, 7 and 8, then we get 8 into 8 into 9, that is 64 into 9, 576. 576 pieces, which is maximum for the given number of cuts. No other combination will give this figure. The logic here is that To get maximum number of identical pieces, the deviation between the cuts should be minimum. The numbers should be as close to each other as possible. In the previous example also, where the number of cuts were divisible by 3, we applied this technique only. We made the deviation 0 between the cuts along the different dimensions. Let's look at a different variety of question wherein number of identical pieces are given and minimum number of cuts are asked. Here we need to figure out the minimum number of cuts that are required to get 125 identical pieces. A question for you guys. Why are we asked only about the minimum number of cuts and not maximum? It is because maximum number of cuts will be one less than the number of identical pieces that we have obtained. In this case, it will be 124 cuts, all made on a single face only. Now, coming back to the question, if the total number of cuts are A, B and C along length, breadth and height, number of identical pieces, that is 125, will be equal to A plus 1 into B plus 1 into C plus 1. Here, the total number of cuts will be A plus B plus C. Now, we know that 125 can be written as 5 into 5 into 5 with minimum deviation between the cuts. This gives us 125 is equal to 4 plus 1 into 4 plus 1 into 4 plus 1. Now, compare this with first equation. We get A, B and C equal to 4. Total number of cuts will be A plus B plus C, that is 4 plus 4 plus 4, which is equal to 12. Let's take an example where the number of identical pieces given are not a perfect cube. Minimum number of cuts required to get 252 identical pieces. 252 is not a perfect cube, so we have to find 3 numbers, or say 3 factors of this number with minimum deviation. First step, 252 is equal to A plus 1 into B plus 1 into C plus 1. Now, 252 can be written as 2 square into 3 square into 7. The least deviation will be when numbers are very close to each other. That is, if I make 2 pairs of 2 into 3, then we will get 6 into 6 into 7. Here you can see that deviation is minimum between the factors. Convert this equation into the format of the first equation. We get 252 is equal to 5 plus 1 into 5 plus 1 into 6 plus 1. So A is equal to 5, B equal to 5 and C is equal to 6. Total number of cuts are A plus B plus C, that is 5 plus 5 plus 6, which is equal to 16. I hope this is clear. Let's move to the next section where we'll discuss about cutting of a painted cube. A cube of side 6 cm is painted red and then cut into smaller cubes of 1 cm each. Total number of smaller cubes so formed are asked. Now, if a cube of 6 cm is cut into smaller cubes of 1 cm, there should be 5 cuts along each dimension, that is length, breadth and height. Total number of cubes formed will be 5 plus 1 into 5 plus 1 into 5 plus 1, which is equal to 6 cube or 216. Now there is one more method which can be used to calculate the number of smaller cubes. Let the length of the edge of the bigger cube be capital N and that of the smaller cube be small n. Total number of cubes are given by whole cube of capital N divided by small n. In this case it will be whole cube of 6 by 1, that is 6 cube, that is 216. If side of bigger cube is of 6 cm and smaller cube is of 2 cm, then total cubes on one side will be 6 divided by 2, that is 3. 3 cubes on length, 3 on breadth and 3 along height. That makes a total of 3 into 3 into 3, 27 cubes. Let's look at the next question. What is the total number of smaller cubes with all faces painted? Here, only the outer surface of the cube is painted. So for every small cube, there will be at least one face which will be inside the bigger cube and it will remain unpainted. Therefore, total number of smaller cubes with all face painted will be 0. There will be no such cube. Let's look at the next question. What is the total number of cubes with 3 faces painted? Now, for 3 faces painted, look at the corners. The maximum number of faces of the larger cube intersect at the corners. Here we can see that all the 8 corners will have 3 faces painted in red. No other smaller cube will have 3 faces painted. So the answer is 8 cubes. Cubes with 2 faces painted. For this, we have to figure out the cubes where 2 faces of the larger cube are meeting. 2 faces of the larger cube meet on the edge. Here we can observe that all the smaller cubes that are present on the edges have 2 faces painted. But we have not considered the cubes that are present at the corners because they have 3 faces painted. So total number of cubes with only 2 faces painted will be cubes on the edges minus cubes on the corner. This multiplied by total number of edges. So total number of cubes on the edges for this case are 6. Out of that, 2 at the corners are subtracted. 6 minus 2 multiplied by 12 gives us 4 into 12, 48. Now there is a generalized formula to calculate the number of cubes with 2 faces painted. It is 12 into capital N minus twice of small n whole divided by small n. Now here 12 is the number of total edges, n is the length of edge of the larger cube and small n is the length of smaller cube. N is the length of edge. From n we subtracted 2 times small n. So length of 2 corners with 3 faces red is subtracted from here. Remaining length n minus twice of small n. It has all the cubes with 2 faces red. This n minus 2n when divided by small n gives number of such cubes at one edge. And this when multiplied with total edges 12 will give the final answer. Let's move to the next question. Here we are required to figure out the total number of cubes with one face painted. Total number of cubes in a single face should be 6 multiplied by 6, 36. We have to exclude the cubes which have either 2 faces painted or 3 faces painted. It can be done by excluding the cubes on the edges and the corners. There are 4 cubes with 2 faces painted on a single edge. And for one face, there are 4 such edges. So, 4 into 4 gives us 16 on the edge. And at the corners, we have 4 cubes with 3 face painted. The total number of cubes with one face painted on a single face comes out as 36 minus 20, which is 16. This is number of one face painted cubes on a single face only. Cubes with one face painted will look somewhat like this. So total becomes 16 multiplied by 6, which gives us 96 as the final answer. Let's try to generalize this. Number of cubes with one face painted can be found out with the help of this formula. 6 into whole square of n minus 2n upon n. Let's understand this formula logically. We remove length of 2 face painted cubes at the edges from the total length. N minus 2n remains, which is the side of this inner square. N minus 2n upon n, it gives number of small cubes in length of this red square. Same number will be there breadth wise also. So taking n minus 2n upon n whole square will give total one face painted small cubes at one face of the bigger cube. And there are 6 faces. So we multiply it by 6. In this last case, we are required to figure out the total number of cubes with no face painted. Now, no face painted means we have to dig a little deeper into the cube, as we are only concerned with the cubes which lie inside this bigger cube and are not exposed to painting. Let's look at this inside portion of this cube. Only the cubes which are shaded in yellow will be the ones which should have no face painted, because the cubes on the edges will have at least one face painted. Let's take out this cube. Now, it is clear that it's a 4 by 4 by 4 cube. That is, total number of cubes will be 64. Alternate way is to subtract the total number of painted cubes from the total number of smaller cubes. This comes out as 216 minus 8 at the corners, 48 2 faces painted and 96 1 face painted. That is 216 minus 152, which gives us 64 as the final answer. Let's see the generalized formula to calculate the smaller cubes that emerge from the inside of the big cube. It should be equal to whole cube of n minus 2n upon n. N is length of edge from which 2n is subtracted to remove the outer painted cubes. So, n minus 2n is the length of edge of inner cube. This divided by small n will give total number of cubes on the edge of inner cube. And in the end, whole cube will give total inner cubes with no face painted. Now I have summarized all the formulae that we have discussed till now based on cutting of a painted cube. Remember, these formulae do not come in handy when the cube is cut in several different ways. Visualization is the only thing which can help you solve advanced questions based on cubes. Before we wrap up this session, have a look at the formulae used when a cuboid of dimension L into B into H is cut into smaller cubes of dimension N into N into N. All of these can be logically derived once you have understood cubes and its formulae. Try to deduce these formulae. Thank you for watching.